online. I'm Shannon, and I'm a cell biology graduate student at the University of Michigan.
And I'm Denise. I'm a genetics grad student here at Michigan. So today we're going to be talking about crystals. Crystals are naturally occurring and can be found outside your home in examples such as amethyst, quartz, diamonds, and rubies. We can also find them inside our homes in table salt and sugar. So Shannon, how are crystals formed?
That's a great question, Denise. So crystals are a group of atoms or molecules that form repeating consistent patterns called crystal lattices. Crystals form through a process called crystallization. This occurs when liquid molecules cool down and form bonds with one another when they clump together. This creates a more stable structure called crystal lattices. We can actually make them in cups in our own home or jars.
So today we're going to be doing 2 experiments using saturated solutions to make crystals. A saturated solution is when there's too much solute within the solution and it can no longer dissolve. So for our first experiment, we're going to be making sugar crystals, also known as rock candy. And yes, these are edible.
And we can actually make them with all the ingredients that you see in front of us. First, you need some sugar, you need some food coloring, some water, some safety pins or clothespins, jars or cups, a heat-safe container, lollipop sticks, and a plate. And now let's get started. First, take a small amount of sugar and sprinkle it onto the plate. Wet half of your lollipop stick and roll it in the sugar and set it aside to dry. Add 1 cup of water to your microwave bowl and place it inside the microwave for 2 minutes. Once boiling, slowly add in your sugar 1 cup at a time. Keep mixing until the sugar is dissolved. Once dissolved, add in your next cup. After adding the second cup of sugar, heat it in the microwave for another 30 seconds. Now add in the last cup of sugar and mix to stir. Once the sugar no longer dissolves in the water, you have finally created a saturated solution. The solution should feel very viscous and thick. Add in your food coloring and mix it all in. Once you pour your solution into the cups, take your lollipop sticks and use the clothespins to place the stick into your saturated solution. Make sure the stick does not touch the sides or the bottom, otherwise your crystals will form along the wall and not on the stick. The reason we rolled the lollipop in sugar is because it gives the crystals a base to allow for the molecules to start forming bonds with one another to create a more stable lattice structure. The crystals will develop over time, and the longer you wait, the bigger the crystals will grow. Place it where it won't be disturbed and just watch it grow. Here's how the crystals look on the 3rd day. You can see that they have started forming on the stick. Sometimes you'll see crystals form on top of the solution, and you can leave it or take it out and eat it as a sweet snack. Humidity and temperature can also affect the growth of our crystals. Great, now here's the hard part. Now we have to wait 4 to 7 days for our crystals to grow. The longer we wait, the more our crystals and therefore rock candy will grow. So just put it off to the side somewhere where it won't be disturbed, and at the end of that week, enjoy your rock candy.
So for our second experiment, we're going to be making hot ice. For hot ice, you're going to need vinegar, baking soda, a plate, as well as a medium pot, and an adult to help you with heating the solution. So hot ice is essentially sodium acetate. Sodium acetate acetate is an essential component within acetic acid, or vinegar. It is the salt within the acid. As sodium acetate is supercooled below its melting point, it suddenly crystallizes. As the heat is released, the crystal structure forms and it starts to look like ice. So let's get started.
First, we are adding baking soda to the vinegar. We need to slowly add in the baking soda because if you add it in too quickly, you'll create a little eruption as the sodium bicarbonate from the baking soda will react with the hydrogen in the acetic acid, the vinegar, releasing carbon dioxide and causing bubbles to form. Add it slowly so it'll only fizzle and not erupt over your pot. The solution we created has too much water, so we need to heat it off. By boiling it for over an hour at medium heat, the majority of the solution will evaporate, leaving behind the sodium acetate. Let the solution boil for about an hour to let the water evaporate. As you can see, crystals are starting to form on the outsides and top of the solution. The solution needs to cool till it is about room temperature. We want to have the solution be supercooled, which is the process of chilling a liquid below its freezing point, without it becoming solid. Once it's in the fridge, set your timer for about 40 minutes or until it's cooled down to room temp. The crystal that formed along the sides of the pot can be scraped and used as a seed crystal for our hot ice crystallization. The seed crystal promotes the growth of the crystal. Once your solution has cooled to room temperature, you're going to want to take it out of the fridge and pour it on your seed crystal. However, sometimes experiments don't work out as we would like. We have to troubleshoot solutions to figure out why. In our case, we believe we didn't evaporate enough water off.
Today we learned that we can create crystals when liquid molecules form bonds when hot saturated solutions are cooled.
We hope you enjoyed learning with us about crystals and saturated solutions. Stay tuned next week for U-MYScI's next video on optical illusions.
Bye.